Hello, viewers and students. So today's video lecture, we are going to see about the four important strategies regularly employed by computer scientists for problem solving skill. So these four skills are nothing but problem definition, logical reasoning, decomposition, and abstraction. So we'll see one by one. What is problem definition? Already we have seen. So problem definition means defining the problem mainly. So there are three important processes involved in defining the problems. So that is recognized by software engineers. One is analysis. That is you have to define the problem, then design. You have to create solution for the problem, then implementation. You have to, that means whatever solution you have created, you have to implement it. So analysis is very important phase because every software engineer so know his successful design and implementation is only possible when we go with adequate analysis. So this is very important thing. And what are the very important requirements in problem definition? They are classified as two types: functional requirements and non-functional requirements. Functional requirements specify the particular task that the software must perform, and non-functional means it defines other characteristics and constraints related to the software. So it includes reliability, safety, security, performance, diversity, all those things. So what are the functional requirements? So when you take a computer, so just consider one application called video player. Okay, so we have a lot of buttons in video player, so which allows the user to play, pause the video, to raise the sound volume, to reduce the volume, all those things. So if you take the play button, so we keep some index for it and also keep some symbols for it. So if we just click the play button, so which causes the video to play. So if the video is not paused, then the video resumes at a point of passing. So if the video has yet to start playing, the new computer video is created and the video begins playing in the window. So long as the video is playing, the pause button or the play button functions as a pause button displaying a pause button image. So there is also a button called pause button. So I can also click those button as well. Then now if you just take the volume button, so you can see the volume. You can increase the volume as well as you can reduce the volume in DP levels. You have run button, quit application button. So what are things, what you can observe from all this video player app is, so clear requirement is needed for an app by the which will be used by the customers, users or clients or even developers. So these are called as the functional requirements. So clear requirement, which must be unambiguous and precise. So clear, it should be the requirements must be clear, consistent, and it must be complete in all aspects. So if you just take these buttons, so it should be clear to the customers. It should be consistent to the customers. Okay. So it must be complete in all aspects. It must function as expected. So how to analyze the completeness? So for that, software engineers used to use a state activity table, which lists all the possible application states against all possible user actions. So we'll see the state activity table for this video player app. So for example, here there are rows as well as columns. So in rows, you can have the rows click play button, pause button. So in the column, first column, increase, decrease, double click video file, double click video, all those things. Then app not executing something. So whichever is mapping, when you click the play button, video can also pass. We can use that button for passing it also. Click pass button, we can make the video to play and also we can make the video to be passed. Similarly, volume increase button, we can make to pass, we can make to play, we can make to finish. So complete analysis we are making. That is called a state activity table. Next strategy is logical reasoning. Logical reasoning, that is the second strategy of the four important problem solving strategy. So logical reasoning means it extends well beyond the obvious connection to computer hardware. Okay, so logical functionality deals with the aspects of logical functionality. So, for example, the program in your digital camera chooses how long to leave the shutter open when taking a picture. So, the uh, programming is done inside. So, that comes under logical reasoning. So, it is also important. So, for example, if instructions are most widely used in logical reasoning, cause effect relationship. So, if that is the case, we will get this output. Otherwise, we'll get another thing. So there are two types of reasoning, deductive reasoning as well as inductive reasoning. So what is deductive reasoning means the ability to apply general rules to particular situation is known as deductive reasoning. So it comes in with the cause and effect. So username and password has been entered. What is the effect? So check to see if usernames and password are valid. Okay, user clicks the close button, then you can, what is the effect? You can remove the closed window from the display. So you have a lot of cause effect relationship. So deductive reasoning is nothing but if the given facts are true and you can apply the correct logic, then the conclusion must be true. So you're just deducting it. Logical inductive reasoning means so you make a conclusion based on the set of experiences or data, previous experience or data. Every quiz has been easy, therefore the test will be easy. So you're just taking some conclusion. The teacher used PPT in the last few classes, therefore the teacher will use PPT tomorrow also. So you're just inductive reasoning. You're thinking, okay? So computer scientists use detection in many ways. For example, a common rule in algorithm is that for certain solution, it's critical to think that one task occur before the second task. So that is sequential form of task, right? So normally for algorithms, we will go with the sequential form like this, sequential rules, all those things. So problem understanding and analysis is very, very important for defining the problem, gathering and the data, finding the root cause, finding solution, and also finding the best solutions. So for that, we go with the problem tree analysis. That is, what is the cause and what is the effect? Cause is the root and effect is the tree. Okay, so like this, we can arrange it. So example of problem tree is, for example, what is the cause? Team members have high workload. That is a cause. So the production is late. That's the main problem. So what is the effect? Have great difficulty in achieving the achievements of the organization. So every problem has some causes, and the main problem we have to list in as the center, and the roots are the causes, and the branch is the effect. This is called as the root cause, and that is tree diagram. So likewise, we can, for every problem, we can draw the tree diagram. So here the core problem in this case is poor sanitary condition in this community. What are the causes are listed as roots? What are the effects are listed as tree? Similarly, another example is lack of sufficient clean water. This is the core problem. Causes are listed as the branch and effects are listed as the root. So I have another tree diagram called objective tree analysis. So here you have problem statements and objective statements. So it is vice versa. So objective tree, the means are the roots and the ends are the tree. So in the problem tree, the main difference between problem tree and objective tree is problem tree will list all the negative statements. But objective tree is optimistic and we will list the positive statements. So you can draw the objective trees also. And we have different constituents of algorithms like a sequence, selection, loops. Sequence, selection, that is iteration. Loops means iteration. What is abstraction? Abstraction means using, that is just showing the significant data alone. Just we are checking with the main important data. So for example, you will represent this abstraction using a case diagram. What is case diagram means? For example, if you take a driver, so cab driver, he'll pick up the taxi from the depot, pick up the next passenger, deliver the passenger and collect fare. He will return to the spot. So this single actor shown in the diagram is the cab driver. So and therefore four use cases to abstract four significant actions performed by the actor. So similarly, if you take student and registrar in a university, so what are their tasks? What is how the registration system and how it is connected to the professor? So the users are called as use cases. And what are the tasks they are doing? Sometimes same task can be accessed by multiple persons. That is clearly represented by the case diagram. So we can draw case diagrams. The last strategy is decomposition. Decomposition, as its name tells, we can decompose the problem into sub-problems and we can modularize it, and we can solve each problems one by one from the lower end or from the higher end. That is top down approach or bottom up approach we can have, and we can end it up. So these are the main ideas, main strategies used in this problem solving. So I hope you got the lecture. Thank you.